Hello and Assalamualaikum. We are from Group 3 and today we're going to present about road safety audit for ECG563 traffic engineering. So our group members consist of 5 students. Number 1 is Fatin Nurshaza binti Shaharuddin. Number 2 is Nur Anis Shafiqah binti Amran. Number 3 is Natalie Chang Sui Yi Anna Enta. Number 4 is Rania binti Muhammad Sufyan Azatra Adi. And number 5 is Alia Farhana binti Akmarul Nizam.
Road accidents have been recognized as one of the major problems globally. They have significant impacts on society, the economy, and the progress of a country. Accidents often occur due to traffic conflicts between vehicles, causing delays and congestion. According to the research paper entitled Road Traffic Accidents in Malaysia Trends by Rohani Kamaruddin, factors such as human error, traffic volume, vehicle and road conditions, and the surrounding environment play a key role in driving behavior, which can contribute to the accidents. In Malaysia, the number of road accidents has been steadily increasing, and the data from the Royal Malaysian Police RMP shows a rise from 414,421 accidents in 2010 to 567,516 in 2019, as shown in the graph. Crashes at roundabouts are a significant issue due to factors such as poor design, insufficient traffic control, and high traffic conflicts. The lack of proper traffic management often leads to severe accidents and injuries at this location. For example, incident from the research paper written by Nurliana Omar entitled Accident Analysis and Highway Safety at Simpang Rantai in 2014, it is ranked the first for road accidents in Malaysia. This unsignalized intersection with the roundabout experienced frequent traffic conflicts, and the absence of adequate traffic control measures resulted in numerous crashes. The second case was in Iskandar Putri at Johor in 2023. A 41-year-old man was killed when his sports car skidded and crashed at a roundabout. Next, Batu Cave Selangor in 2023, a lorry collided with 11 cars and a motorcycle at a roundabout, injuring 3 people. And the last one in Shah Alam Selangor during 2018, traffic accidents at roundabout near UiTM Shah Alam main gate, where a dump truck appeared to have lost control and overturned, damaging nearby structures including signboard and part of the landscape. And the research by the Malaysian Institute of Road Safety Research, MIROS, highlight that roundabouts can be especially dangerous due to unclear signs, poor design, and traffic management issues. These cases demonstrate the critical need for better design, traffic control, and management at roundabouts to reduce crashes and improve safety. Hence, this is why we need to conduct road safety audit to identify potential hazards and implement preventive measures. The objective of this project are to enhance road safety and reduce crash occurrences, thereby improving the overall well-being of all road users through road safety audit. Number 2, to identify potential hazards at the existing roundabouts and address them proactively to prevent the area from becoming accident-prone. And the last one is to ensure that the safety needs of all road users are thoroughly integrated into the planning, design, construction, and operation phases of road projects.
My part of the road safety audit focuses on the geometry layout located near UiTM, between Hotel UiTM and Seroja area. This roundabout is designed with following key components. First is the central inscribed circle diameter of 30 meter, which governs its overall size and capacity. It includes 10 number of lanes, with each lane being 3005 to 3006 of millimeters wide, ensuring smooth vehicle circulations. The central islands serve as a defining feature of the roundabout, aiding in controlling traffic flow and improving safety. The entry and exit radius are critical for controlling vehicle speed at approach and departure points. The width allows for safe vehicular maneuvering around the central islands. In addition to its vehicular design, this roundabout also incorporates several pedestrian-friendly and safety features. We can clearly see that there are pedestrian walkways, rumble strips, splitter islands, and also aprons. This geometry layout ensures that the roundabout is functional for both vehicles and pedestrians. However, during this audit, we'll examine if these features are performing optimally and if there's any room for safety improvement. Task 2 is to determine the suitable experiments and approaches to identify problems related to road safety issues. So our approaches to this is first traffic volume analysis, and second is the spot speed analysis. The first approach is traffic volume analysis. So the purpose of this is to help determine the number of vehicles entering and exiting the roundabout during specific periods, off-peak and peak hours. Insights from these studies can help to propose solutions like lane expansion, signalizations, or even alternate routes if the roundabout is overburdened. Next is our spot speed analysis. So this spot speed studies capture the speeds at which vehicle approach, navigate, and exit the roundabout. So the outcome of this is to understand the speed patterns, aid in recommending interventions like speed bumps, warning signs, and recalibrated design geometry to control vehicle speeds effectively. Speeding vehicles reduce reaction times, increasing the risk of rear end and side impact collisions in roundabouts. The roundabout in UiTM Shah Alam have pedestrians crossings or students on foot nearby, where high vehicle speeds pose a significant danger.
Good day everyone, my name is Fatin Shaza and today I'll be presenting on the topic of traffic volume analysis. In this study, we utilized several apparatus to conduct the analysis effectively. This included a mechanical hand counter to record the vehicles entering and exiting the roundabout, a digital distance measuring wheel roller to measure the dimensions of the roundabout, and a digital stopwatch to monitor timing in 5-minute intervals over a duration of 1 hour. The experiment was conducted at the roundabout near College Seroja, UiTM Shah Alam. First, the dimension of the intersection were measured, followed by labeling the direction of vehicle movement at the roundabout as D1, D2, D3, D4, D5, and D6. Observation points were carefully set out for each direction to ensure a clear view of the designated road segments. Each direction was observed for a total duration of 60 minutes and traffic volume conditions were recorded. The data collection form was structured to differentiate between daytime and nighttime data. The right-hand column presented daytime observation while the left-hand column documented nighttime observation. Let us now move on to the presentation of the collected data. This slide displays a sample of the data collected during the day during the study. This complete data set along with the calculation can be accessed via the provided link. The summarized data derived from the raw observation is presented here. Table 1. This table highlights the passenger car unit PCU values used to calculate traffic volume PCU per hour for direction D1 to D6. PCU is a standardized unit in traffic engineering allowing different vehicle types such as car, bus, motorcycle, and trucks to be converted into equivalent passenger car values based on their impacts on the traffic flow. Table 2. This table shows the total number of vehicles and the flow rate of each direction. The flow rate is critical measure in traffic engineering, quantifying the number of vehicles passing a specific point within a given time. This metric is used to assess traffic demand and evaluate roadway performance. Table 3. The peak hour factor PHF for each direction is displayed. The PHF is a significant indicator in traffic engineering that evaluates traffic variation during peak hours. It measures the concentration of traffic flow within the busiest period, helping assess congestion severity. A low PHF close to 0.25 suggests sudden surge in demand, while high PHF near 1.0 indicates evenly distributed traffic flow. Next, we analyze the differences between daytime and nighttime data. The flow rate during nighttime showed a significant reduction compared to a daytime, primarily because most people had already returned home and offices were closed during the night. It is worth noting that no data was recorded for direction D4 and D5 at night, as these roads operate only from 7 a.m. to 7 p.m. Similarly, the traffic volume during the night was significantly lower during the day. Lastly, let us examine the PHF comparison between daytime and nighttime data. Interestingly, the PHF value did not exhibit significant differences between the day and night. As previously mentioned, the PHF indicates the severity of congestion during peak times. The analysis revealed that the traffic flow at the roundabout was evenly distributed throughout the day and night. This consistency is reflected in the PHF values, which confirm the traffic distribution remains uniform regardless of the time of the day. Thank you.
Spot speed analysis is a method used in traffic engineering to measure and analyze the speed of vehicles passing a specific point on a road. For this study, we collect the data for 1 hour during the day and night at 3 directions. Firstly, we collected the speeds of 100 vehicles on a road using a laser gun. The data range from 10 km per hour to 50 km per hour. For better analysis, we group these speeds into bins such as 15 to 19 km per hour and so on. These bins allow us to see how the speeds are distributed. The first graph we will create is the frequency histogram. This graph uses bars to show how many vehicles fall into each speed range. For example, if 55 vehicles were traveling between 25 and 29 km per hour, the bar for this range will rise to 55. From this graph, we can immediately identify speed patterns and spot if there are any outliers, such as drivers going significantly faster or slower than the rest. Next, we have the frequency distribution graph, which takes the same data but presents it as a smooth line. On this graph, the x-axis represents average speed, while the y-axis represents the frequency percentage. From the graph, we can get the modal speed or speed that occurs most frequently in a set. Our third graph is the cumulative frequency graph. This is a step graph that shows the running total of vehicles as we move through the speed range. This graph is particularly useful for determining the 85 percentile speed, which is the speed below which 85% of vehicles are traveling. By combining these three graphs, we can gain a deeper understanding of driver behavior and use the insights to improve road safety and efficiency. The data from direction 3 and 5 also use the same concept. Lastly is the data during the night. After 1 hour, we can conclude that the number of vehicles coming from UiTM main gate decreased and there is no vehicle from direction 5. It is because the most user for that road is the workers.
Next is the road safety elements issues and mitigations. The first issue is speeding leads to the risk for vehicles, pedestrians and cyclists as high speeds increase the possibility of accidents. To address this, rumble strips can be installed before entry points to alert the drivers to slow down. Also, speed cameras should be used to enforce the driver. The second issue is street lighting. Inadequate street lighting can contribute to accidents, particularly during night time. As you can see from the video, there is a dark spot area especially from College Seroja to the UiTM main gate. This can be mitigated by installing bright LED street lights around critical areas like roundabouts and ensuring even lighting to eliminate dark spots. Roadside safety is another concern, with steep slopes near roundabout which can be particularly dangerous. These steep slopes create a risk for vehicles losing control and veering off the roadway. To address this, the recommended mitigation measure is to install crash barriers or guardrails. These safety features act as a physical buffer, preventing vehicles from leaving the roadway. Visibility issues due to poor road markings at night were also identified. Enhanced reflectivity of road markings can improve visibility during nighttime and adverse weather, providing better guidance to drivers. Finally, uncovered drains on road surface, especially hazardous to motorcycles, present a significant safety risk. Bumps will occur when any of the vehicles are passing by the proper uncovered drains. This can be mitigated by ensuring the grades are flush with the road surface and maintaining road condition to prevent unnecessary hazards. All these measures aim to create a safer road environment for all users.
In conclusion, the road safety audit conducted at the Hotel UiTM Seroja roundabout identified several critical issues including high traffic volume, speeding, poor lighting and unsafe road conditions. Traffic volume analysis revealed congestion and accident risk at entry and exit points, especially during peak hours. Speed analysis showed that vehicles entering and exiting the roundabout at high speeds increased the likelihood of collisions, particularly near pedestrian crossings. Additionally, inadequate lighting, poor road marking, uncovered drain, and steep roadside slopes were found to compromise the safety of all road users. To address these issues, several mitigation measures were proposed. These include installing rumble strips, speed limit signs, and speed cameras to manage speeding, upgrading streetlights to bright LED fixtures, and enhancing road markings for improved visibility, and installing crash barriers, guardrails, and flash grids to enhance surface and structural safety. Implementing these solutions is expected to significantly reduce accidents, improve road user safety, and contribute to the development of safer transportation infrastructure in Malaysia. Thank you.